We will study formal languages, automata theory. Introduction to automata theory. Automata theory. Let's move on to the next level. What is automata theory? Study of abstract computing devices or machines. Automation. This is the word coined by the scientists. An abstract computing device. A device need to even be a physical hardware. A fundamental question in computer science. Find out what different modules of machines can do and cannot do. The theory of computation. Computability versus complexity. Alan Turing was a scientist, great scientist, pioneer of automata theory. He was a father of modern computer science. He was an English mathematician, studied abstract machines called Turing machines even before the computer existed. Heard of Turing test. These are the languages that were derived for the computer before they even were discovered. An alphabet is a set of symbols or word. Sentences are strings of symbols 0100. A language is a collection of sentences of finite lengths of all constructed form of finite alphabet symbols. Grammar can be regarded as a device that enumerates the contents of languages, nothing more, nothing less. Chomsky hierarchy, a containment hierarchy of classes of formal languages, regular DFA, context-free PDA, context-sensitive LBA, recursively enumerable TM. The central concept of automatic theory. An alphabet is a finite, non-empty set of symbols. We can use symbol sigma to denote an alphabet. The binary sigma 0, 1, all lowercase, alphanumerical DM and molecule letters. We can use strings. String or a word is a finite sequence of symbols chosen from sigma. Empty string is epsilon. Zero set. Length of string W denoted by main. W mod is equal to the number of non-epsilon characters in the string. Example, mod x is equal to 6. XY concentration of two strings XY. Powers of alphabet. Let sigma be an alphabet. Sigma k, the set of all strings of length k. Sigma star is a universal set. Languages. L is said to be language over alphabet sigma only if L is a subset of sigma star. That is a universal set. Let L be the language of all strings consisting of n zeros following by n ones. Let L be the language of all strings equal numbers of zeros and ones. Psi denoted by empty language. Given the string W belongs to sigma star and a language L over sigma decides whether or not W belongs to L. Example, let W equal 10011. If W belongs to the language of string with equal number of zeros and ones. Now we'll discuss finite automata. Some applications. Software for designing, checking the behavior of digital circuits, lexical images of typical compiler, software for scanning large bodies of text for pattern finding, software for verifying systems of all types that have a finite number of states. Example, stock market transactions, communication network protocols. This is the action of finite automata examples. On and switch. On off switch. If you on, you push. Off, you push. On. Action state. This is the state of and on is state and pushes action. Modeling recognition of word then. Start, start state. T, transition. intermediate states, then the final state is denoted by double zeros. Structural expression, grammar, regular expression, unique style to capture city names such as Palo Alto City. Start with the letter, string of other letters, other states to eliminate words to them with two-letter state code. Now, what we studied, let's have a quick summary about it. Automata theory in a historical perspective. Chemistry hierarchy, finite automata, alphabet string, word sentence language, membership problems. Finite automata. How will discuss more about finite automata. It's formally a state diagram that comprehensively captures all possible states and transitions that a machine can take while responding to a stream or a sequence of input symbols. Recognizer for language, regular languages. Deterministic finite automata. A machine can exist in only one state at a given time. Non-deterministic finite automata. There are two FAs, deterministic, non-deterministic. A machine can exist in multiple states at the same time. Deterministic finite automata consists of Q, a finite state set of states, sigma, a finite set of input symbols, Q naught, a start state, F, a set of final states, beta, a transition function which is mapping between Q cross sigma Q. DFA is defined by five tuples. These are the five tuples. What does DFA do on reading an input string? Input word W is it master. Question is W accepted by DFA? Steps. Start at the start state Q naught. For every input symbol in the sequence W, do compute the next state from the current state given the current input symbol in W in the transition function. If after all symbols in W are consumed, the current state is one of the final states F, then accept W. Otherwise reject W. Regular languages. Let LA be the language recognized by DFA, then LA is called regular language. Locate regular languages in Comiskey hierarchy. Example 1. The first example. Build DFA for following languages. L. W, W is a binary string that contains 0, 1 as substring. Steps for building a DFA to recognize L. Decide on states. Q designates start state and final state. Theta decide on the transitions. Final states. Same as accepting states. Other states same as non-accepting states. Regular expressions. 0 plus 1 star 0 1 0 plus 1 star. DFA of string containing 0 1. What makes the DFA deterministic? This is the pattern. Start Q naught 1 is 1. Then 0. Then push 0 1. Then final state Q2 0 comma 1. What is the language allows the empty string? Q, Q naught, Q1, Q2, sigma, start state equal Q naught, F equal Q2, transition table. Examples. Clamping logic. Clamping circuit waits for an one input turns on forever. However, to avoid clamping on surprise noise, we will design a DFA that awaits for two consecutive ones in a row before clamping on. Build a DFA following languages. LW1W is a bit string which contains the substring 11. State design Q0 which was the start state. Q1 was the middle state. Has never seen 11 but the most recent input was 1. Q2 has seen 11 at least once. Build a DFA foreign language string that has even number of ones and even number of zeros. Extension of transition to paths. Beta dash Q W destination state from the Q and the input W. Work out example 3 using the input sequence W equal 1001. This is the language of DFA. DFA A accepts string W if there is a path from Q0 to the accept or final state that labeled by W. LA equal W belongs to F. LA or string that leads to final state Q0. Let's start with a non-deterministic finite automata. Non-deterministic finite automaton NFA is a course of non-deterministic, implying that machine can exist in more than one state at the same time. Transition could be non-deterministic. Q I 1 Q J Q K. It can go both ways. It is non-defined state. Non-deterministic finite automata. Non-deterministic finite automata consists of Q of finite states, sigma a finite set of input symbols, Q not a start state, F set of finite states. Transition function is mapping between Q cross and subset of Q. NFA is also defined by this 5 tuple Q 7 Q naught F. How to use an NFA? Input a word in W in sigma star. Question is W acceptable by the NFA? Step start set start state Q naught. For every input symbol in the sequence W, do determine all possible next states from all current states given the current input symbol in W, the transition function. If after all symbols in W are consumed and if at least one of the current states is final state, then accept W, otherwise reject W. Regular expression 0, 0 plus 1 star 0, 0 plus 1 star. Y is non-deterministic. Start this start state 0, 0, Q 1 new final state. What happens if state Q1 and input of 0 is received? Q equal Q naught Q1 Q2. Epsilon is 0 1 start state Q naught F equal Q2. Transition table. This is the transition table. Note: explicitly specifying dead state is just a matter of design convenience. One that is generally followed in NFA and the feature does not make a machine deterministic or non-deterministic. What is a dead state? DFA for recognizing keyword while Q0 W Q1 H Q2 Q3 Q4 Q5 any other symbol Q dead any symbol in NFA for same purpose Q0 W Q1 transition into a dead state are implicit. Build an NFA for the following languages L equal W, W ends in 0 1. Other examples keyword recognizer example if then else file for include etc strings where the first symbol is present somewhere later on at least once. Extension of sigma beta to NFA paths basis. This is the basis. Let Q0 W P1 P2 PK PIA SI for I to K. Then Q0 is S1 join S2 join tested SK. Language of an NFA. An NFA accept W if there exists at least one path from the start state to an accepting or final state that is labeled by W. Ln advantages and caveats of NFA. Great for modeling regular expression, string processing, graph, lexer, analyzer. Could be a non-deterministic state machine be implemented in a practice? Parallel computer could exist in multiple states. At the same time, probabilistic model could be viewed as essentially non-deterministic state machines example. Toss of a coin, roll of a die. Now discuss differences between DFAs and NFAs are equivalent in their power to capture languages. Differences of DFA and NFA. DFA, all transitions are deterministic. Some transition could be non-deterministic. Each transition leads to exact one state transition could be lead to subset of states. For each state transition and all possible symbols should be defined. Not all symbol transition need to be defined explicitly. If given defined will go to a dead state, there is just a design convenience not to be confused with a non-deterministic except in particular last state is an S. Sometimes harder to construct because of the number of states. Except input if one of the last state is an F. Practical implementation is feasible. Generally easier than a DFA to construct. Practical implementation has to be deterministic convert to the DFA or in the form of parallels. Thank you so much for joining.